x minus 1 then. This is called the rational function. And you guys are going to see this later on in the course. I think in chapter 5. So let me try to sketch a graph for you. X-axis, y-axis. You're going to have something called the horizontal asymptote. You have something called the vertical asymptote at x equal to 1 right here. Okay? X is bigger than 1. This is 1 right here. 0 right here. Okay? X bigger than 1, you have a positive number, so I think the graph is going to be like this. Like this. This one is at -3. See how I know? I plug in x equals 0. I got -3. Okay. And by the way, this graph, because the hyperbola, okay? We're going to learn this type of graph later on in the course, or maybe the next course in pre-calculus, okay? The name of the graph will hyperbola. Okay. But it's not the main thing. The main thing is we're looking at the domain and the range. For the domain, we're looking at the x value. Functions say what? All real numbers, right? Except for 1, because 1 makes the denominator equal to 0. If you're tracing along the graph, see what? You can go all the way from -infinity, getting closer and closer to 1 first, so never hit 1. And all of a sudden, you jump over 1 and keep moving to the right. Domain is anything from -infinity to 1, and then 1 to infinity, except for 1. Same idea, you're looking for the range, you're looking up and down. Okay? And now we're looking at y value, right? Start from -infinity, can go up, go up, go up, go up, go up, getting closer and closer to 0 value for y, but never hit 0, always a little bit below 0. And then jump over 0 and keep moving up. So the range is -infinity to 0, and then union from 0 to positive infinity. Another word, the range is all real numbers except 0. Okay? So for now, we're going to do an informal way to get to the domain and the range of the function. And the informal way is what? You have a function, you try to sketch a graph. And by looking at the graph, we can have some idea of the range and domain. And I keep saying that this method is informal because the graph does not represent the whole function. It's just whatever you see is just a point of the function. And you, by observation, you give a conclusion on the entire function. By knowing just a part of it, that's just inappropriate. But, well, it's true for now, okay? So, we stick with this. But I keep saying this because I want you guys to move on later on. We really have to do is algebra. Use algebra to find a domain and range, not just looking at the graph. Okay, now go back to our method by looking at the graph. So, the next question is, how do I know if something is not a function or not? How do I know if something is a function or not? Okay? Or you have something and people say, no, it's not a function. How do I know? We have something called the vertical line test, number 3. Vertical line test. Okay. Again, we go back to our graph, okay? And the vertical line test is whenever you have a graph and you want to determine if that graph is a graph or function or not, you're going to kind of draw some, imagine that you draw some vertical line, and if the vertical line intersects the graph at 2 points or more, then it's not a function, okay? So let's write it down. Given a graph of an equation. See, now I call it an equation, right? It may be a function, it may not be a function, I don't know. If there exists a vertical line that intersects the graph at 2 points or more, at least 2 points, equation is not a function. It's not a function. Otherwise, this is a function. Otherwise, it is a function. Means what? When you draw the vertical line, when you test all the vertical lines, it's intersect the graph at just 1 point or less, it's a function. Of course, you cannot draw all the vertical lines. The explanation right here kind of give you a counter example way. Whenever you can find the vertical line intersect the graph at 2 points, it's not a function. Then the opposite of it is going to give you a function. Example or counter example. Let me just draw a couple of pictures. This line is a function because it doesn't matter how you draw the vertical line, it's intersect this line at 1 point. Okay? Parabola right here is a function because it doesn't matter how you draw the vertical line, it will intersect this parabola is 1 point. This parabola right here is not a function because I can find a vertical line that intersect the graph at 2 points. So this is the function, this is the function, this is not a function. How about circle? Circle is not a function either because I can find at least one vertical line that intersect the graph at 2 points. This is not a function either. Okay. So for now, by observation, by looking at the graph, at least you can determine whether this is a graphical function or not, right? And something called the vertical line test. You see, I can draw a vertical line right here, a vertical line right there. Intersect 1 point, 1 point. Doesn't matter where you draw, it's going to be 1 point. And if you can draw a vertical line that intersects the graph at 2 points, or maybe more than 2, maybe 3, then it's not a function. Okay. That's the vertical line test. So for now, we're mainly using our observation to decide. Okay, let's move on to number 4. The book called it the different quotient of a function. And I'm glad you guys will see this a lot when you get to calculus 1. Different quotient of a function. Okay, so this is the formula. F of x plus h minus f of x over h. And I'm glad that this is how we used to define something called derivative in calculus, calc 1, I think. Like you have to learn something about limit and then take the limit when h approaches 0. But that is for the future. For now, I'll just try to introduce to you this formula. Okay, got the different quotient of function. So let me explain the formula to you, just basically algebra. So say I got f of x, example, equal to, use the same one, 2x minus 1. Okay? And then what? This means a function where x the input. Whenever I got an input, I multiply the input by 2 and subtract 1. So what do I mean by f of x plus h? Now that the input is not x anymore. The input is x plus h. So I follow the formula. I got what? 2 times x plus h and then minus 1. Okay? So, plug into the formula. You got f of x plus h is 2 times of x plus h minus 1. And then subtract. Let me put a big square bracket in here to indicate this. The whole thing right here is f of x plus h, and then subtract. I got another quantity right here. What is my f of x? F of x is 2x minus 1, right? And everything divided by h. And let's simplify it. This is 2x plus 2h minus 1, and then subtract 2x, and then minus negative 1 becomes plus 1. Everything divided by h. And let's simplify. Okay, simplify. 2x, cancel out 2x, okay? And the top is what? 2h, right? And then minus 1 plus 1 cancel out as well. So it's 2x gone, negative 1 plus 1 is gone. So what we have in here, 2h over h, which is equal to 2. Okay. And you know what? This is actually the slope of the line. Okay. So this formula has got the different quotient of a function, and later on we use that to define something called the derivative of a function. Okay, we're going to learn that later. For now, all I want you to know is the formula, and then do the algebra with it. How about one more example before we move on? How about this? F of x equal to x squared plus 1. All right, x squared plus 1. So what is f of x plus h? So if x is the input, I will square up the input and then plus 1. Now x plus h is the input, so I'm going to square up x plus h and then plus 1. Okay? So plug into this formula, I got x plus h squared plus 1. That's the whole thing, and then subtract what? X squared plus 1, and then everything divided by h. Okay? So we can simplify this, okay? For this out, x plus h squared, x plus h times x plus h. For this out, right? X squared plus xh plus another xh plus h squared. Okay? For your first, and then outside, inside, and then last. Alright? So this is x squared plus 2xh plus h squared. This one becomes x squared plus 2xh plus h squared, and then plus 1, and subtract x squared, subtract 1. So minus, distribute it into the two terms. We have that. Then divided by h. Okay? Now let's simplify. X squared cancel out, right? Subtract x squared plus x squared cancel out. Plus 1 minus 1 cancel out. So we got 2xh plus h squared all over h. And I glance actually in here we can factor out something. On the top I factor out the h. I got 2x plus h, and then divided by h. And then this is equal to 2x plus h. And keep in mind that if you write this way, we are implying that h cannot be equal to 0 already, okay? Because if h equals 0, we cannot divide it by 0. H is non-zero. Okay, so the algebra may be a little bit complicated. And in here, I only give you two pretty simple examples. If you face more complicated function, which you will see later on, maybe in next course, calculus 1, you see other type of function. We want to find a different quotient of function, you do this way, right? And one more time, key word for main reason for this topic right here is something called derivative, as you guys are going to learn in Cut 1. Okay, let me move on. I'm going to talk about the very last part of our section today. We're going to do some algebras on functions. Not everything on function, okay? We're going to do some very basic fundamental algebra on function. Basic means what? You do what? Addition, subtraction, multiplication, and division on function. And that's it. But I claim that later on you have more. You can have a composition function, those kind of things. But later on, of course. But now just a basic one. So number one, we talk about addition and subtraction. So basically, you guys have two functions. Say f of x is equal to, say, 2x plus 3, and then g of x equal to x squared minus 4x and minus 5. So I'll give you two functions. Okay. So to add two functions together, we denote notation as f plus g of x. And what do we mean by this? We means what? We take the function f plus the function g. Okay. So we got what? This means f of x plus g of x is equal to what? 2x plus 3 plus x squared minus 4x minus 5. The first part right here is f, the second part is g, okay? And of course you can combine the like terms. You have what? 2x plus 3, 2x plus 3 plus x squared minus 4x minus 5, x squared, 2x minus 4x minus 2x plus 3 minus 5 is negative 2. Okay, so this is the sum of the two functions. Okay, and you can try it with numbers. So what is f plus g of 0? Plug in 0 in here, right? This is f plus g of x. 0 minus 2 is 0 squared minus 2 times 0 minus 2 is equal to negative 2. Okay. You can also calculate it using this fact right here. You can calculate f of 0 first. What is f of 0? Now f of 0, look in here. 0 for x, right? So 2 times 0 plus 3 equal to 3. What about g of 0? G of 0 is 0 squared minus 4 times 0 minus 5 is equal to negative 5. And I claim that if you have the sum of two functions first and plug in the input, or you plug in the input on each individual function and then sum up later, it's going to come up to the same answer. Look, f of 0 plus g of 0 is equal to f of 0 is 3, g of 0 is negative 5. Right, this way make it. Okay, this is equal to negative 2. It's the same. Okay? Similarly, instead of do addition, you guys can do the same way for subtraction. But be very careful with the algebra when you do subtraction, alright? So if I got f minus g of x, and what do we mean by this? We take the function f of x, we subtract the function g of x, okay? And our f of x is 2x plus 3. You guys see the way I write it, always in parentheses, right? To avoid any possible algebraic mistake that we may have. G of x is x squared minus 4x minus 5. Okay, simplify. 2x plus 3 minus x squared. Now double negative, make it positive 4x, and then plus 5. Okay. Negative x squared plus 6x plus 8. Alright, now I'd like to try the other way around. What if I want to do g minus f of x? G minus f of x will be g of x minus f of x. Okay, now it's the opposite, right? See what we have? G of x is x squared minus 4x minus 5, and then subtract f of x, which is 2x plus 3. Simplify. X squared minus 4x minus 5, subtract 2x, subtract 3. I'm distributing that negative sign into the two terms. And then combine the like terms, simplify. I got x squared minus 6x minus 8. You guys can compare the two different functions in here. This is g minus f. You got x squared minus 6x minus 8. This is f minus g. You got what? Negative x squared plus 6x plus 8, right? It's opposite of each other. Just like when you do subtraction, you got what? 8 minus 5 is 3, but 5 minus 8 is going to be equal to negative 3 when you switch the order on subtraction. They're not the same anymore, they're the opposite of each other. Okay. The additional inverse of each other. Are we good? Okay, now let's talk about multiplication and division. Multiplication and then division. Okay, so with multiplication, if you do f times g of x, very similar to addition and subtraction, what are we doing in here? We take the function f of x, we times the function g of x. Okay, and this is going to be f is 2x plus 3, and g of x is x squared minus 4x minus 5. Okay, and of course, if possible, go ahead and simplify. 4 will multiply them all out. 2x times x squared is 2x cubed. 2x times negative 4x is negative 8x squared. 2x negative 5 is negative 10x. And then 3 times x squared is plus 3x squared. And then 3 times negative 4x is negative 12x. 3 times negative 5 is negative 15. And then you combine the like terms. You have, let's see, 2x cubed minus 8x squared plus 3x squared is minus 5x squared. And then negative 10x, negative 12x, negative 22x. And then minus 15. This is the product of f dot g of x. Okay? Say if you want to calculate what? F dot g, f times g of 1. You can plug it here, right? 2 times 1 cubed minus 5 times 1 squared minus 22 times 1 minus 15. So this is 2 minus 5 minus 22 minus 15. Oh boy. Minus 42 plus 2 is negative 40. Okay? And like addition and subtraction, you can actually calculate g of 1, f of 1 first, and then you plug them together, you still have the same answer. Try it. F of 1, this is f of x, right? F of 1 is going to be 2 times 1 plus 3, which is 5. G of 1 is 1 squared minus 4 times 1 minus 5 equal to what? 1 minus 4 minus 5 is negative 8. So f of 1 times g of 1 is 5 times negative 8. I mean negative 40. It's the same thing. Okay. Product of two functions is the same on both ways of calculating. You can multiply the two functions first and then plug in the input. Or you can plug in the input on each function and multiply. You still have the same answer. Okay. Now, move on to the last part of the day. Talk about division. Very similar to multiplication or addition or subtraction. We denote this way: f over g of x. And what do we mean by this? This is f of x over g of x. And this is 2x plus 3 over x squared minus 4x minus 5. Okay? And what about g over f of x? It's going to be g of x over f of x, which is x squared minus 4x minus 5 over 2x plus 3. Okay? And we have what's so-called the rational function in here. We're going to learn more about those type of function later. And of course, the domain and range will be changed. Okay? When you have a new function, you may not have the same domain or the range anymore. And that's all I can tell you about the division right now. Or you see what? F of x over g of x is going to be the reciprocal of g of x over f of x. So those two are not the same. But for multiplication, similar to addition, f times g is the same thing as g times f. Okay? But division is kind of like subtraction. F minus g is the opposite of g minus f. And then what? F over g is the inverse of g over f. And you have a different function. Okay? That pretty much for our section 3.1, talking about some basic properties of function, and definition of function, and the vertical line test, domain and range of function. That's the very first thing that we learn of function. So let me stop our video clip today. Thank you for watching, and as usual, please email or any other form of communication if you want to ask for any question for anything about the course, about the lecture. please feel free to do so to us. Okay? Thank you and have a good day. Bye-bye.